Hello everyone, I'm making some videos on equations. We've got a bit of work to do out of the textbook, and it gets to this time of the year where we've learned a lot of these skills separately, and that's been a nice comfortable way to do things because we can just focus on one particular skill at a time. But now with this topic on equations, we are integrating a lot of our learning, and we've got to, I like it because we have to work in a more natural mathematical way. We've got to understand that we've got a toolkit that we've got to bring out at the right time and use it in the right kind of way to do our work, okay? The next thing I've got to say to you is that equations are quite predictable. They help us map out the world that we know. We know that we can measure one thing and plug it into a formula, and we'll know the output of that, and we'll know our answer, okay? And it's useful for predicting things and doing a range of work like that. So we're at the very beginning, and we're going to start really simply. And the very first thing that I want to impress upon you is I've lost my bit of paper, but I'll find it and write something on here. I'm just going to put the equal sign on a bit of paper, and let's talk about that for a moment. Nice and big here with my black texter. I've got a light board, and I'm going to show you some more stuff in a minute, but hopefully the camera can pick that up. There's an equal sign, and what we're saying, and I think most of us know this, is that say if I've got 2 bricks and then I've got another 3 bricks that are exactly the same, I can put them into one group, and that's equal to 5 bricks. We're used to doing that kind of work, and we're used to doing something like writing out things like 5 times 4 is equal to 20. So we've been using this sign, and we understand it in one way. And what I need you to think about now is just open your mind up a little bit and think about, there's a left-hand side to your equation, the equal sign's in the middle, and then there's a right-hand side. So there's some stuff we could write 2 plus 3 on this side, and we could write that's equal to 5, and that would be true. We would interpret that to be true. So as we go along with equations, we've got to start thinking about these guys as more, and what that equal sign's telling us to do is think about this, that in the middle we've got the equal sign, so that would be the middle of that set of scales there. The arm on the left hand side and the right hand side has to be level. They have to balance each other out. For that to be, for whatever we're working on, for that to be true, we need to keep that arm up the top here, we need to keep that level. So I'm going to use these pictures quite a bit, and in mathematics as we go along with this, you can manipulate the left hand side and the right hand side of the equation, provided you do exactly the same thing to each side. So we'll do some work on that in another video. But just before I move off and get behind the light board and show you some really sort of set examples, I want to point out one mistake that I see all the time at the beginning of this kind of thing. So we've got 3x here is equal to 12. And we can solve this by inspection, and either in knowledge of our 3 times tables, I think there's a 3 out the front here, that might help us out here. We might solve that, and we might think about that as 3 times 4 is equal to 12. So the mistake that I see, and quite quickly students understand that they've got to swap the letter out for the number. So often they'll do this. They know they've got to swap it out. So they swap it out and they think of this as 34. They read this as 34 and then they get confused because they know if I've got 34 bricks on the left-hand side of my equation here, that's not the same as having 12 over here. So that doesn't make sense to anyone. And this is the kind of rookie mistake that gets made straight up. So when we see some algebra, and we've studied this before, I think it's an important little reminder to understand how that's, when we do the substitution, that pronumeral gets swapped out for the value, but there's a times sign in there. So 3 times 4 is the correct way to do this. And now everything sort of makes sense to us. So I'm going to jump behind the light board and show you a few more things to get you started on equations and deciding whether they're true or false. Okay. This is an introduction to algebra, so we need to do a little bit of a refresher here. Pronumerals are just the letters, okay? And we are seeing, for example, something like this, 7x plus 2, and that's equal to 16, for example. Okay, so in your primary school, you might have done something like this, where you've just had the box, and you've asked to figure out, well, what is the value of, what is the number in here that needs to be multiplied by 7 to make all this true? So you might come in here and go, oh, well, that's got to be 7 times 2. Okay. What we're going to get used to doing is when we see this, we might write comma x equals 2. And there's our solution to that equation. Now it's really important, some of the things we're going to do now, and I pointed this out in the introduction, that has an equal sign in it, so it is an equation. So let's have a look at some other examples here really quickly. For example, 2 of something, as long as they're the same, is this is true. And we might write true. 2 equals 2. So if there were 2 1 kilogram weights on our set of scales here, and this is 2 kgs, on the other side the scales would balance if we had another 2 kilogram weight there. We understand that, and that's the nature of the game that we're playing. And I think in that introduction I said to you something like, we're kind of used to doing this stuff. So I'll just grab another bit of the board here. We're quite used to writing this out for example, when we're doing our times tables. 10 times 2 is equal to 20. Saying this stuff. And what we've got to understand now is that we're a little bit more detail about what that equal sign means and what this equation means. And we have a left-hand side to the equation and a right-hand side to the equation. And what we say is the left-hand side must equal the right-hand side if we're going to say things like this, if things are true, okay? And that is the game that you're playing. So, for example, let's change it a little bit. Let's write another equation. We might write this, and if we're constructing it, we would do the arithmetic here and go 100 minus 90 equals 10. Okay, but instead of that, and I might just rub that out for a minute, what you're presented with is not asking you to get the answer. What you're presented with is 2 times 5, for example. Now, we know the left-hand side is equal to 10, and perhaps we could take another line here and write this. 10 equals 2 times, and look at the right-hand side now, and 10 equals 10. And that statement would be true. We could even, because this is really simple kind of stuff, we could just look here and say that's true, or give it a tick or something. So that's the kind of thing that we need to do. Now, in the exercises, you're given some algebra. For example, you've got 5b plus 2 is equal to 22. Okay, and in there you've told b is equal to 4. So I would just encourage you to write a statement like that when you see it. And now you're going to do the substitution step. Now, here's another little reminder about algebra. This is an implicit multiplication. There's a time sign here when we do the substitution, and I talked about that in the introduction. So 5 times 4 is 20, add the 2, and we're at 22. You could stop there, or you could go to this step and write it out, and you could finally go 22 equals 22. And there's a complete set of workings for you to answer that question. So what tends to happen is that you see the 4 here, and in your mind you're going times 4 in there, and I understand that, and it's nice that you can see the answer, but sometimes you're asked to write these next lines out just to demonstrate that it's true and kind of prove that to everyone on the page. So don't see it as being lazy, just seeing it as the game that you've asked to play, and try and set things out this way. Now, some of the questions that you're going to be presented with are going to be asking you to write an equation. So they're worded questions, and they're really simple questions. So what we've got to keep in our heads is we want to write a pronumeral, use a pronumeral, and we need to understand this idea of balance, that the left-hand side is equal to the right-hand side. So a really simple example is that we're buying some chairs, okay? And we're going to buy 6 of them, and they all cost, in total, they cost like $546 or something. It's one of the questions in your book. So how do we set this up? It's kind of really simple. All the chairs, when we purchased them, they all added up to a certain dollar value. There were 6 chairs, and chair starts with the letter C, so I might use the letter lowercase c to write something like 6c equals 546. And often with those questions, you're not asked to solve them. And we don't have to go through the process of dividing each side, but if you are, we can divide each side by 6 to get our final answer, and our chairs is 540. That's going to be $91 per chair. All right. So that's a whole lot of steps taken care of there, but just be really careful with the questions. They might be just asking you to construct the equation, and that's all you're asked to do. So now I just want to do something to finish off this video real quick. There are some really good questions at the end of this exercise in the textbook, and they get you to explore this idea of how many solutions can an equation have. I think this is the actual working algebraically or working mathematically. So let's just explore this with a few questions. So let's start here. We've got x, which represents some number, plus 5, and that's equal to 11. So for this to be true, the only solution here is x equals 6. Okay, let's try another one. We've got 12 subtract x equals the same number again. Okay, that's how I read that question. So I can only see one solution here, and there's no stress if you're just trying a few different numbers and try the simple ones, 1, 0, all those kind of things. But I can see here that value of x needs to be 6, because we've got 12 minus 6 is equal to 6. And that is the only situation where I can see that is going to be true. Okay, nice and simple one solution there. So let's look at a situation where we could have a couple of different solutions. So some letter times by the same prime numeral is equal to 100. I see 100 as a square number, and we could tidy this up and we could say a squared is equal to 100. And so I think one of those solutions is a is equal to 10. And I've got one of them, but a could also be equal to negative 10. And what we need to think about here is applying our knowledge of negative numbers, and we've got a negative 10 times by a negative 10. I'm just pointing this out, and this turns into a positive 100. I'm just writing a little bit differently to show you that two negatives are multiplied together to give a positive answer. So there's a situation where you've got multiple solutions, and just finally we can play a couple more games here where we can do a question that possibly gives us an infinite number of solutions. So a times a is equal to a. A can be any number, including 0. So we've got a full range of numbers here that would satisfy this equation. So, and they go from the negative side of infinity to 0 all the way to the positive side of infinity. There's an infinite number of solutions to that equation. Okay, it's not a very good equation, but it helps demonstrate that idea. And just finally, let's do perhaps one more. Let's say 3x is equal to 3x plus 1. Okay, there's no solutions here. And we're up to the very first one that we've sort of gone around in a circle now. There's no value of x that would satisfy this equation and make the left-hand side equal to the right-hand side, because whatever that value is, on the right-hand side we're always going to add one more to it. So we're close, but we're only one away, and we have to understand that the left-hand side is not equal to the right-hand side. So in that situation, you could come here and put a line through that equal sign and say they're not equal. So I'm just going to draw that a little bit bigger so you can understand that. If the left-hand side is not equal to the right-hand side, we can use or modify that symbol to indicate that's what's happening. So there's some things to think about, and because they're questions towards the end of the exercise, they're just questions to help open your mind up a little bit about the world of algebra. Okay, thank you.